AAA games are well known for their well-designed worlds and their excellent graphics. Let's take a look at Dark Souls 3 here, and you can see the detailing on the walls, the detailing in the different environment assets here. As the light rays come in through the windows and cast onto the walls, you can see how every rock picks up light and every rock casts a shadow. But whenever we look closer, we can see that these rocks are really just sheets of geometry that have a texture applied to them. They don't have actual depth to them. This is not real rendering of geometry. It is a normal map that's being rendered that the light is playing off of, so it's very easy to see whenever you look obliquely at the geometry that's in these games. Okay, you can even see over here, these rock walls have very apparent tiling in the textures just there in front of my character here, and these rocks are clearly completely flat. The geometry that they're on is simply mapped there, again by the use of these normal maps. So what we're going to talk about today are two different ways of baking normal maps. One of them is by using Maya and actually modeling the content and then mapping it down into it. Another way is a designer that we can do this, but we're going to be focusing on creating a high poly model and mapping it down onto our low poly model like in these walls. To begin with, in Maya, I'm going to create the destination or the target mesh. That is the low poly mesh that's going to be efficient to run in the game. So this is a mesh that's actually going to be in the game environment in Unity or Unreal or whatever game engine you're using. So to start with, I'm going to just create a polygon sheet similar to the sheets that we looked at that made up the walls and some of the floors in Dark Souls there. We want to simplify this for optimization in our game engine. To do that, we'll pop into our attribute editor, select polyplane 1, and change the subdivisions down to 1 each. So it's just a simple piece of geometry, one face. And this is going to serve as our low poly model, our low poly object. So we're going to rename this to, let's make this a floor. So floor underscore low poly. Okay, and that's that set up. The next thing we can do is duplicate that, Control and D, and this is going to be our high poly. So we can hide the floor by pressing Control and H to hide, Shift and H to show, and then we've got our high poly selected. So the idea of this is you have a simple low poly model that will be the one that's rendered up in the game engine, and the high poly one, it has all the detail, so it's used to model the details and then bake it down into a map. If that doesn't make sense at first, we'll see how it actually applies later on in this tutorial. So let's keep this nice and simple. I'm going to go to Mesh Tools and Insert Edge Lip. I'm going to click on my options box there, and I'm going to add in 2 edge lips. And I'm going to pop those along this side and along this side to create a 9 squares of tiles. That's 3 by 3. Next thing I'm going to do is use my extrusion tool. So if I go into face here, I can select all of my faces. And then I'm going to extrude. If the dialog box doesn't pop up here like it hasn't on mine, there may be a wee issue with your history settings. If it does, you'll be able to select keep faces together or deselect that. You see keep faces together is usually selected. I'm going to deselect it, so each one of these faces will be an individual object. Then in my attribute editor here, what I can do is I can pull down this local scale to say 0.8 on the Y and, on the X and on the Y. And you see I get individual tiles out of that. Now they're completely flat at the moment. I can either use my local translate here, or I can use my W tool to pull those up. Now one neat trick, I just Control and Z there to undo. One neat trick is you can actually use local translate. So if I do 0.02 or something like that to pull those up on the Z axis, you can use this random slider here and it will randomize the direction of the extruded faces. So you see if I pull this up, it randomizes the height and basically the orientation of those tiles so they look a little less orderly. So that's kind of what I want to go for this. I don't want it to be perfect, or you can simply rotate the faces and move things around yourself. So what I have here as a result is some detail to this floor. I could add more detail by, say, selecting faces or edges and going in and using things like the bevel tool. There's all sorts of ways that you can add extra detail there into your models. So I'll add a wee bit into that, and I'm just going to stop there. Now, one thing that you want to do before you do any baking is make sure that your edges are set up exactly the way they want to be. So at the moment my edges are looking a little smooth. So what you can do is go to Mesh Display and then Harden Edge. And what that will do is it will harden the edges of your model so that you get all of the extra geometry that you've just put into reflected in the normal map that you're about to bake. So make sure that for rounded edges they are softened, and for hardened edges they are nice and hard. Actually, for this edge here, I'm going to just soften that. There we go, and we should see a difference reflected in the final normal map there in that middle tile, just to show you that there is a difference. So next thing to do is to bake this detail down onto our low poly floor tile sheet. To do that, both of these pieces of geometry need to be in the same space, so I'm just going to show this, Shift H, and you can see here that my low poly floor, when I have it selected, is inside exactly the same space as the high poly one, so they're occupying the same area, and this will be really important whenever it comes to baking. So with my low poly model selected, I want to go change my workspace from Maya Classic to Rendering Standard, and it will give us a new set of options here. So you'll see up above here, I'm just going to close this render setup and property editor there, so I have a wee bit more space. You'll see at the top here we have the lighting / shading option, and under baking there's transfer maps. So again, I have the low poly floor, the low poly item selected first, and then I'm going to hit transfer maps. Okay, so what having that selected does is it automatically puts it in as my target mesh. The target mesh is the one you're going to be using in game. It's the one that you want to bake down onto. That's why it's the target for the baking. Then the source mesh here is going to be the source of all the detail. So the source of my detail is my high poly. I'll select that and click on Add Selected. Then if I scroll down, you can see the different maps that you're going to output. By default, you may have a whole bunch of maps listed. I'm going to go ahead and remove all of those. You may only have a diffuse, that's fine. Remove that all, so all you have is these options. And then I'm going to select normal. Under my normal map settings here, the first thing I'll do is choose a file name and location. So file type I want to be PNG, and then the file name is going to be floor_normal. And I'm going to find a location for that, and then hit save. Now that won't actually save this bake yet, that's just saving the file location. So the file format's now set to PNG. I don't want to mess with the include materials thing, that's fine, that's just for extra details that might already be on your material. Map space I'm going to keep as tangent space. You'll also see object space. We'll maybe talk about that in another lesson. And use my common settings, that's fine. Now this is a good option here, connect output maps. I'm going to do it to assign shader. What that means is as soon as I bake this, I'm going to see the result in the shader, in the material that I have attached to my low poly object. Okay, so it's instantly going to do that. You'll probably have new shader by default, but you'll need to apply that in Maya. So it's handier, I find, because you may be doing multiple bakes to just go to assign shader. And then Maya common output, let's see what we got. The map size, I'm going to switch to 2048 by 2048 is all good for this. Keep aspect ratio, yes. Transfer and world space, all of these settings are generally fine. They may need tweaked if, for instance, you're not getting some of the detail through and you need to change the sampling quality and other things like that. Okay, so advanced options, let's see. I think by default it's closest to envelope. I'm going to do inside envelope, then outside envelope, and I'll explain what that means in a moment. Let's go up and take a look at what this envelope thing actually is. Okay, so if I scroll up to the target mesh, you see there's a display option here, and at the moment it says display mesh. What I'm going to do is I'm going to display, you could do envelope, and you'll see the envelope, or do both. So let's go to both. Alright, so you can't see the envelope at the moment because it's right on the surface of my low poly model, but if I change this percentage up with the search envelope, you'll see that this sheet comes up off of my low poly model. So what this sheet is an envelope or a cage. And it is basically the area that it's going to project down from. If you imagine little lasers coming down from this polygon sheet, the red one, down onto my low poly sheet, it's going to pick up all the detail that's in between them. So you can do this for more complex objects. We're just using a polygon plane at the moment for simplicity to try and get some results. So just imagine this envelope as a kind of cage under which all the detail needs to be. So if my envelope is too high, I'm not going to pick the detail up because I'm going to lose some of it as I'm kind of projecting down here. If it's too low, it's going to clip through and I'm not going to get all of the detail picked out. It's going to cut it off here and then it's going to look flat everywhere above the envelope. So what I need to do is find the number or use a slider to find the right height that I'm going to get everything in. 3.8 almost gets it, but you can see this little corner isn't quite taken in, so I'm going to try 4 here. And you see that's the perfect height for this envelope, just about getting all the detail in and no more. So we'll see how this works out in the bake. I'm now going to scroll down to the bottom and double check over all my settings, it's looking fine, and I'm going to hit bake. So that baking process will take anywhere from a couple of seconds to a few minutes, depending on how complex. I mean, it could take an hour if it was a very, very complex object and your computer wasn't that quick. And you'll see what it's done actually is it's applied the map to my high poly because it shares a material with the low poly one. So I'm going to fix that in a second, but let's take a look at the low poly and see how it turned out. So if I pull this out here, you'll see that the low poly is now modeling the look of the high poly, and yet it's still a flat sheet. So let me just fix the high poly's texture here by adding a new material. Let's assign a new material, and we'll go for a Lambert just like the other one. Okay, great. So now we can get a better comparison of the two. So you can see that the lighting plays off the surface just the same really as it does with the detailed model here, and yet this is just a flat single face surface. Okay, so if you look at it at an oblique angle like I showed in Dark Souls 3 there, you're not actually going to see any surface geometry, but it's going to be a lot more efficient to run in game. And as we know, it's all about running a game at 30 to 60 frames per second to get that good user experience, especially if you're playing a competitive or a multiplayer game. You don't want your game slowing down, therefore you don't want every wall to have individually modeled tiles or blocks or bricks or whatever it is. So this is a great way of your player being able to look at something from straight on, like a wall, or being able to walk over something like a floor, see all of the lighting data and the cast shadows, but that's all just been put on through a normal map. Okay, so if I attached the standard material to this, assign existing material, and I'll assign that one that this one has, you'll see it's still a flat object. It's only whenever I bring in that normal map that it shows up with that lighting data. So it's not perfect, it's not quite the same as having actual height to your model, but it looks substantially the same and it will get you that great performance in game. So we specified a location for that normal to be saved out, and I've just opened that up here. So this is what the normal map itself looks like. Here you can see the hard edges that we had marked using the mesh display option in Maya, and you can also see those softened edges there where I used the bevel tool and then I used mesh display and soften edge there. You can see the effect that that's had on the normal map, effectively making that look like a smoother edge. So we can now go back into our modeling view here, just Maya Classic. So if, for example, you hadn't got this, you had got a blank material and you need to create a material using the normal map that came out because you forgot to make that selection that automatically applies it, what you'll end up with is, let's see, assign a new material, and I'll just assign this Lambert here. Okay, so I've got this Lambert 3, it is, right? So I'm going to rename that material to let's just call it floor underscore material. Okay, and what I want to do is take a look at the bump mapping. So in bump mapping I can select this option here, and then I can go to File. Within my options here, you see Use As. I'm going to select Tangent Space Normal. That's what we output there. And under Bump Value, I'm going to click that little option there. I'm going to choose the image name, and I'm going to go and find my image. So there's my floor underscore normal map. I'm going to open that, and you'll see that will now render up on my surface there. If you're not getting it rendering, maybe you don't have textured mode on, so remember, number 4 in your key is wireframe, number 5 is shaded display, and number 6 is textured display. So you'll need textured display on to be able to see the lighting changes there from your normal map applied. Let's talk briefly about what the normal map is actually doing. So the normal map is purple because of this shape here. So this is a normal sphere, and it basically shows how the light is going to react whenever it hits the surface of the geometry. So we've kept it simple with one face. So for each face, the normal direction, it is represented by this purple color. So the normal direction is just coming straight out of the face. That is, it is perpendicular to the face. So if I jump into Maya here, the normal direction of this plane is this green direction here on the y-axis currently for me. Okay, so that coming out is a normal direction for this face. So that means everything that is facing that direction is going to be that purple color that we can see that makes up most of this face. So that means that these squares here are going to be basically flush with the surface of the geometry. If there is any change in angle, it's going to be represented by a different color. So for instance, we can see this color here, which is from about here on the color wheel. Okay, so that means that this is going out that way. The purple color here, which is from the very center, represents the stuff that is coming directly up out of the surface of my geometry. And then to the left here, you can see this kind of like bluish color here, and that is directing light out to the sides like that. Then you have this color that directs out right, and then finally you have the magenta kind of color that directs down this way. Okay, so basically light will come from a light source. It will look at the direction of the light source, and then it will compute what way it needs to render shadows based on the color of the normal map, and it will then render that across your surface, and that also interacts with other things like your metallic map, your roughness maps, and your color or albedo maps. The great thing about having this sphere is you can actually paint your own normals. So a lot of people would do this in hand painted textures. This here I could make with shapes in Photoshop, and then I could simply paint it by color picking from this wheel here. Just use this as a color wheel, and whenever I know that light is to be directed up, I want to make it this color. The angle will depend on how bright the color is or how far to the top here, where the angle down would depend on how far down I go here in this color wheel. Okay, so this will direct light in the direction that I wanted, and I could brush that on, but the way we've done it here is by creating the geometry and then baking it down. In Substance Painter and Substance Designer, you can also paint or design normals based on patterns. That's another way of doing it, and we'll take a look at baking in Substance Painter in another video. Let's finish by looking at a couple of other examples of how you can create these high poly versions of your model and then bake them down onto the low poly. So you'll see here 3 different sections of flooring, or they could be tiles on a wall. This is the first one, the second, and the third. So the lower one in each case is just a single face polygon. So that is our low poly version. It's the same for each one, just one single face, they're completely flat. And then above that we have this model that's been made by using edge loops and extrusions, as I showed you before. Okay, and you can tell that this is a softer square here because we use the mesh display and soften edge around those parts. And that carries across into our map. And you can see how realistic the map looks. It works really, really well until you get down at those very oblique angles, very, very high angles, and then you can start to tell this is actually modeled, while as this one is a flat texture. But usually as a game character, you're not even able to get that close to the floor. And sometimes what people would do is add in the odd tile object that's actually a mesh to make it look like the whole thing is a bit more three-dimensional, but that works very effectively. Then we come across to our second version here. So you can see that what we've done is we've started off using a single poly tile. So if I can just select that here. Okay, so this is just a sheet. But then on top of that, we have a bunch of different objects, which is totally fine. You don't need to create it all from the same object. So here these slabs are just cubes that have been merged down through. I put a few edge loops in them, and then I put some details like these cracks that I've rendered up, and I put a hole in this one. So let's see how that's worked out. In the low poly version, this is again just a flat sheet, a flat face, and you can see as we move around that the lighting is very, very similar. You couldn't really tell that that is just a two-dimensional face, and it looks very much 3D until again you go at a very oblique angle, and then you find out that it is indeed textured on using normal mapping, but it works really effectively even whenever you're just merging objects through. So one place that this can be really helpful is, say you need screws or bolts in a sheet of metal. You can simply grab a sphere, a half sphere, and then you could move that into the corners of your object and kind of make that a little bolt impression on your model, and then bake that down into your low poly. Rather than adding to the poly count with lots of small details, that's generally how you would do that if you're modeling, say, a sci-fi corridor or spaceship or something like that. So placing these things through the surface and then baking down into your low poly model exactly the same way. Just make sure that everything is the same object, so use your combine function there to combine all of the objects in this into one object before you bake. Now we'll look at example 3 here, and what we have is an object that has both extruded or pulled out edges around the edge here, and then this bit in the center is actually sunken into the shape. And you can see the lighting works really well on that too. Okay, it effectively looks the same up here in the model version as it does down here in the low poly version. Now, the reason that I included this example is because this is actually falling below the level of the geometry. So that was just to show you that the envelope can reach in underneath the faces to a certain degree, and you can use the settings in Maya to decide how deep you're going to go with that, okay, in the envelope settings. But you can see I've depressed that down. This is completely flat, and yet I still get the impression of a sunken in object. So this works quite well with what we've got here, but you can see definitely at a high angle that it is indeed flat compared to this, where you see the bottom of that object actually slopes down in. So there's limited use to normal maps. Whenever your geometry is sticking out a lot, or if it's impressed a lot like it is here, you're generally better to add some extra geometry in and then bake the little details. So there are limits to normal maps. I just wanted to show what they could do in Maya and some of their limitations. Now, if you had an object that was, say, pointing out of your map like this, okay, you would not bake that as a normal map. There's no way that something that sticks that far out of the surface, or if it was down into the surface, would bake well. Okay, it would just look ridiculous. You'd see these random little points here with dark shadows around them. So that's not going to bake well. The details need to be close to the surface of the original. So really it is for adding detail. It's not for adding limbs and poking out pieces of geometry. For that, you'll need to actually increase the geometry of your model. This is what the normal maps turned out like from those 3 examples. So you can see here how the different angles are represented in different shades of blues, magentas, and purples. Looking back at the example that we gave of Dark Souls 3, you can see just how simple some of the geometry is. All of these shapes here are effectively just sheets. They are big sheets of geometry. All of this is not geometry data. That is all normal mapped down, either again using Substance Painter, which we'll go over later, or using the technique that we showed in Maya. Okay, so all of these, this geometry here is actually very, very simple, and would look something like this, perhaps. And that's really all there is to it. So I'll just do this front face here. That's all the geometry data that there would be for that shape, and then the rest of it is normal mapped into existence. So all of this detail here is probably normal mapped on with these kind of textured parts here. All of this detail here on the pillar is detailed in. These pillars are essentially just concentric rings of cylinders built up. Okay, so very, very simple geometry really that is created quite quickly and then is made detailed through the high poly and through the textures. You can see this ground plane here. All of this is, again, just a big polygon sheet that has been cut into shape and has a texture applied to it. None of these little bricks are actual bricks. They've maybe been modeled in something like ZBrush and then baked down, or they've used Substance Designer. That certainly in more modern games they would use Substance Designer to bake in these details through normal maps. This entire scene is made of very simple shapes. If we do an overlay of what the geometry would look like, you can see that the geometry is very, very simple right across the scene, and it's really just large surfaces that have detailed maps on the top of them. So you can see how good some of these maps look with this lighting data that is picked up from the normal maps here. You can see where the lights are highlighting. You can see the shadows down in the cracks of the models. So you can get very, very detailed 3D looking surfaces whenever this entire surface is actually just a big flat surface. There is occasions, you can see here, where they have actually put some blocks of poly models in there to kind of break that up and make it look a wee bit more three-dimensional, but substantially it is a flat surface. Again, you can see there a couple of 3D parts they've put in, but most of this will just be a flat plane that has been normal mapped with detail. So I hope that has been helpful in explaining how normal maps kind of operate and how you can create basic normal maps in Photoshop using baking from high poly down to a low poly model.